चलिए बहरा, please write the chapter's name, electrochemistry. Before that, can you please have your cameras on? I've started the focus mode. मेरा कैमरा भी आ रहा है. Yeah, please write here electrochemistry. आप मैच देख रहे थे क्या राबिया? Yes, Rabia. Were you watching the cricket match? No. I was late because I was watching the cricket match actually. I was like 5-10 minutes late. Okay. Waiting for Alia, Aisha, and Rabia. So Parker, you always use a phone only to study?
Yes, sir.
आप ऐसे कहीं तो रख सकते हैं ना, आपने ऐसे रखा. I mean, you have just kept it like this. You can ऐसे तो रख सकते हैं ना, फोन को क्यों रख सकते हैं ऐसे sideways, just screen की तरफ. क्या ख्याल है? Mariam Parker, you can keep it like this. ऐसे कहीं पे.
Sir, but I'll have to hold it in my hand.
Why you will have to hold it in your hand? You don't have wall or किसी चीज का तो सपोर्ट हो सकता है ना. एक कॉपी का सपोर्ट से रख दीजिए, किसी चीज के भी सपोर्ट से रख दीजिए आप. हाँ, okay, fine, not a problem, Rabia. What about others? Alia, Hafsa, अच्छा आयशा के इसमें Hafsa, I'm just waiting for you. ठीक है. Fine. So we have electrochemistry. Now, please listen very carefully. This chapter is very easy. लेकिन very easy, and also it is also having a lot of weightage in your examination. ठीक है. This chapter will take a bit of time, but it is going to be very easy. Each and every concept will be clear. You will not have anything left. हर एक concept, छोटी छोटी चीजें भी ना बिल्कुल आराम से clear करते जाइए. Don't leave anything, any concept. है ना? If you did not understand some concept, please stop me and ask me about it. Otherwise, it will be related to some different concept, and वहाँ पे आपको difficulty होगी. ठीक है. And another thing is that if this chapter has been taught in your school, and if you have any preconceived notion about this chapter electrochemistry, then उसको थोड़ा side में रखने की कोशिश कीजिएगा. If you have memorized a few formulas, उसको भी थोड़ा side में रखने की कोशिश कीजिएगा ना. Please keep it a bit side apart, and we will start electrochemistry बिल्कुल fresh. ठीक है, from the very starting. Now, when we study about chemistry, we generally study about matter and its change. No need to write any of these things. Matter and its change. And whenever a change happens, it is accompanied with a change of energy. It is accompanied by some kind of energy. Either energy is given or energy is given in the system, or it is released by the system. So there is involvement of energy. And when we talk about energy, then we can study energy in two different ways. We can study energy as transfer of energy from one body to another, or we can study the energy as transformation. What is the meaning of transfer of energy? For example, if you have a hot body here and you bring some cold body, so heat will flow. So this is the transfer of energy from hot body to cold body. This is the transfer. Now this transfer of energy you have already studied in the chapter thermodynamics, which was in your 11th standard, thermodynamics. सही है? वहाँ पे ये होता था ना, flow of energy. In transformation of energy, you have also seen this transformation of energy in 9th standard itself. When you had an object and it was falling down due to gravity, then potential energy was getting converted to kinetic energy. याद है सबको? All of you guys remember this? Yes or no? Please tell me. जी, Alia, Aisha, Hafsa, and Rabia. याद है? सबको याद? अरे हाँ ना, कुछ तो बोलो.
Yes, sir.
जी, याद है ना सबको? ठीक है. Similarly, here also we are going to learn about the transformation of energy. We are going to learn about transformation of energy, and in transformation of energy, we'll learn about we will write chemical energy, But this chemical energy is not actually only chemical energy. It is called chemical potential energy. But since the chemistry book is using chemical energy, we'll have to write it as chemical energy. Chemical energy is used to transform into electrical energy, and electrical energy will be used to convert to chemical energy. What is chemical energy? Chemical energy is given out or is taken, whatever chemical energy, whenever we say chemical energy, it is basically reactions. So when reactions, some reactions, if they happen, they release energy. So they will release the energy, and that energy will be converted to electrical energy. There are some reactions which need electricity, which need energy, and those reactions will require energy, and then only the reaction will happen. Fine. So here we are going to learn about, in electrochemistry, we are basically going to learn about the transformation of chemical energy into electrical energy and electrical energy into chemical energy. Electrical energy into electrical energy into chemical energy. Another thing that you have to remember very nicely is that about electricity, how do we generate electricity? We can generate electricity only if there is a spontaneous change. For example, water is flowing down a dam. Water is flowing down a dam. Then there is a turbine which moves. Turbine, it moves, and then by the movement of turbine, there is a generation of electricity. One thing that you can see here, is there anyone who is pulling the water down? क्या वाटर को नीचे लाने में कोई आदमी की मदद हो रही है, या फिर किसी आदमी को एनर्जी लगाना पड़ रहा है, or it is happening on its own? Tell me guys, this water is flowing down on its own, yes or no?
Yes, sir.
And whenever something happens on its own, that is also known as spontaneous change. Spontaneous change. So we will use spontaneous change, and we generally use spontaneous change to generate electricity. And in this particular chapter, we will be talking about spontaneous, specifically spontaneous reactions. And these spontaneous reactions will be used to generate electricity. Is this clear? Yes or no? Please tell me. यहाँ तक अब अब बात आती है कि spontaneous change. For example, you have seen a very simple reaction, very simple analogy है. देखिए, sodium, it loses electron to form sodium positive. अगर आपको याद हो, NaCl का formation आपने पढ़ा होगा ना. Na, it has one valence electron. Chlorine, it has how many? 1, 2, 3, 4, 5, 6, 7 valence electron. There is a transfer of electron from sodium to chlorine, which leads to the formation of Na positive and Cl negative. And this transformation, it is a spontaneous change because sodium has low ionization enthalpy. Chlorine के पास high electron gain enthalpy. That is why the transfer of electron from sodium to chlorine is a spontaneous change. आराम से हो जाता है. And then you get sodium chloride. कितना पढ़ा है आप लोगों ने पहले से? हाँ या ना? All of you please tell me. हाँ या ना, जल्दी जल्दी बताएं. राबिया, मरियम पारकर, हफ्सा. ठीक है, अब ध्यान से. Let us suppose what is happening here. Scientists thought that, okay, fine. Electron is going from sodium to chlorine. Now, this particular thing is completely theoretical. We are just starting to think about electrochemistry. How can we use a spontaneous change that is happening in chemistry to generate electricity? So they said that, okay, fine. Sodium, from sodium to chlorine, what is moving? Electron is moving. So completely theoretical. It has no reality. समझिए सिर्फ बात को. Theoretically speaking, if I have sodium in one container, if I have chlorine in another container, and I join both of these things with a wire, if I join both of these things with a wire, electron will move from sodium to chlorine. Electron will move from sodium to chlorine. And from 10th standard electric current and electricity, you know that if electron moves in this direction, current will move in this direction. So if the electron is moving, then obviously what is flowing? Current is flowing. ये समझ में आया सबको? हाँ या ना? Simple example से समझिए. From sodium to chlorine, sodium is giving electron to chlorine. So if I attach a wire between sodium and chlorine, electron will move. And the movement of electron itself is what? Current. हाँ या ना, जल्दी बताएं. Yes or no? Hafsa, Parker, Rabia. Hafsa, is this clear? Yes or no? Hafsa? Yes, Hafsa, am I audible? Are you there or not there? ठीक है. Slowly we will move on to another reaction. Now, obviously, we are just talking about theoretically what is happening from sodium to chlorine. I also think that See, chlorine is a gas, sodium is a metal. How are we going to connect these things? So those logistics are coming here. We have also seen one reaction. Here we have copper sulfate solution. If you remember this reaction from your 10th standard, copper sulfate solution, and we dip a zinc rod. कुछ याद आया नहीं याद आया? Guys, tell me. Aisha, Hafsa, Parker, Rabia, Alia. Zinc in copper sulfate. Zinc in copper sulfate. Does it ring any bell? कुछ भी याद आया नहीं याद आया किसी को? Copper sulfate is blue solution. Yes, I can't hear anyone speaking anything. Copper sulfate is blue color solution. If I add zinc here, then the blue color disappears. नहीं याद आया किसी को?
Yes, sir.
You remember something, guys? All of you? Okay, so what was happening here? Then you wrote a reaction zinc plus CuSO4. Then आपके मैडम ने बोला होगा because zinc is more reactive. Zinc come above in the reactivity series. It has the ability to displace copper, ZnSO4 and copper. याद आया नहीं याद आया? You have seen this reaction, yes or no? Please tell me.
Yes, sir.
Now, what is actually happening here? Please see. Zinc, here we have copper. So copper and SO4. So you have Cu2 plus and SO4 2 negative. That is why it is balanced and there is no overall charge here. So copper 2 plus is here. And when copper 2 plus is going to copper. So what is happening? Copper 2 plus is eating 2 electrons in order to get to copper. Similarly, what is happening with the zinc molecule? Zinc atom, it is zinc and it is getting converted to Zn2 plus and 2 electron. So here also there is a transfer or there is a movement of electron from zinc. Zinc is giving 2 electron and it is going towards what? It is going towards copper. It is going towards copper. So now this particular movement was also inspired. है ना? यहाँ से भी आपको inspiration मिला that we can move from zinc to copper to positive. If I give 2 electrons like this, है ना? I can give 2 electrons from zinc to copper to positive. Now this was the particular point where we can start adding instruments. What are the instruments that we can add? Please see here. Just a second. Okay. What are the instruments that we can add? Please see. We need to have zinc. There are students who are going to check. Why are guys disconnecting? Okay, Hafsa and Parker are back. Alia got disconnected. See here, guys. We need to have zinc and we need to give electrons to copper. So we took a container. We took a container like this and one more container. Don't do anything. You just need to listen here. No need to write. Just relax. No need to write anything. Here, guys. Now, थोड़ा हम थोड़ा अच्छा बनाना चाहेंगे. You have to wait a bit. इसको ऊपर जाने दीजिए. I will have 2 containers. Mariam Khatun, why are you so late? Yes, Mariam. Mariam Khatun, why are you so late? Why are you so late? तो yes sir बोल रहे हैं आप. Here, guys. We have some solution here. We have some solution here. Sleeping. स्कूल से आके थक गए. Okay, fine. Alia, no problem. Guys, if you remember from the last class, Mariam Khatun and all, You have to keep the cameras on for the classes. Please turn your cameras on. Just wait a bit, guys. थोड़ा सा हम लोग wait करते हैं. वालेकुम अस्सलाम साद. You are also very late. कैमरा तो ऑन है मेरे वहां, तो कुछ आ नहीं रहा है लेकिन आपके कैमरे में. वीडियो इज ऑन बट देयर इज नथिंग इन द वीडियो. ठीक है. Now please here guys, what we have taken this setup, you will understand this particular setup. Here we have taken ZnSO4. Here we have a solution of what? Zinc sulfate. And here we have taken its own metal, zinc metal. Here we have taken CuSO4, and here we have taken copper rod. Here we have zinc rod, and then we have copper rod. Okay, sir. Now, please listen what is happening very slowly. आराम आराम समझिए क्या हो रहा है. First of all, as soon as we add zinc into zinc sulfate, as soon as we add zinc rod into zinc sulfate, there will be an equilibrium between, there will be a release of electron like this. Zinc will lose 2 electrons like this. Why? Because zinc is a metal. Metal has a tendency to lose electron. Okay, metal has a tendency to lose electron. Now, please see what is happening. Zinc is getting converted to Zn2 plus. So from zinc rod, I am getting Zn2 plus inside the solution. From zinc rod, I am getting Zn2 plus inside the solution. And the electrons are here itself. Is this clear? Yes or no? Please tell me. इतना सबको clear है? हाँ या ना, जल्दी बताएं.
Yes, sir.
Right. See next. Next is when we have electrons in the rod, the electrons will start moving. This is not the flow of current. This is the flow of electron. Please understand very carefully. The electrons will be moving like this. And they will move in the wire because obviously electrons, when they have a conductor in front of them, they will obviously move towards the wire. They will move in the wire and they will reach the copper compartment. They will reach what? They will reach the copper compartment. And what they will see in the copper compartment, please see. They will meet, see here. We are getting 2 electrons and 2 electrons will meet. First of all, they will meet copper. So copper will say, okay, fine, I will eat the electrons. Electron will say, no, you cannot eat me. You cannot eat me. Why you cannot eat me? Because copper, you are a metal. You have a tendency to lose electron. You cannot eat electrons. Copper will say, okay, fine. The 2 electrons will move down. It will reach the solution part of the copper rod. And there it will meet 2 things. Copper sulfate has copper 2 plus and SO4 2 negative. So it will meet SO4 2 negative. SO4 2 negative will say that, okay, fine, I will react with you 2 electrons. The electron will say, SO4 2 negative, you are negatively charged. How can you react with me? Then it will say, okay, fine, I will not react. Electron is also negatively charged. SO4 2 negative is also negatively charged. Then third is copper 2 plus. Now, when copper 2 plus will get the 2 electrons, it will easily eat the 2 electrons because it is positively charged and electron is negatively charged, and it will form copper. It is going to form copper. Now, what is happening in the copper rod? In copper rod, the copper 2 plus ion is getting deposited in the copper rod. Itna sabko samajh mein aaya na jaldi. Whatever is happening in the zinc rod, zinc compartment and the copper compartment. In the zinc compartment, zinc is giving 2 electrons as Zn2 plus. Zn2 plus is going to the solution. 2 electrons are moving towards the wire, through the wire, and as it is moving through the wire, it will reach the copper compartment. In copper compartment, it will meet 3 things. It will meet copper, it will meet SO4 2 negative. The 2 electron will not do anything with these 2. The copper 2 plus will eat the 2 electrons to form copper. And what is happening here? Copper 2 plus, it is getting deposited in the copper rod. Is this clear till here? Yes or no, please tell me. Yahan tak sabko clear hai?
Yes, sir.
Now, as the electrons are flowing, then what will happen? The bulb will glow. What will happen? If the electrons are flowing, then bulb is going to glow. Is that clear? Yes or no? Please tell me. ना किसी का माइक ऑन ना कोई हाँ ना बोल रहा, क्या ही करें हम इनका.
Yes, sir.
ठीक है. Next ध्यान दीजिए. Bulb will glow. It will glow for a while, but after a while the bulb will stop glowing. The bulb will stop glowing. Why is that? Why will the bulb stop glowing? There are two main reasons. हाँ से सुनिए जरा क्या होगा. ठीक है. After a few minutes, the bulb will stop glowing. Why? Please see. What is happening in the zinc compartment? Can you tell me, guys? In the zinc compartment, the Zn2 plus concentration will increase. Keep your mic on. I need yes or no. बहुत quickly. Keep your mic on, all of you guys. In zinc compartment, the Zn2 plus concentration will increase. Yes or no? Please tell me.
Yes, sir. Yes, sir.
Whose concentration is increasing? Cation or anion? Whose concentration is increasing? Cation or anion? If the concentration of Zn2 plus is increasing, whose concentration? Cation or anion? Positive charge, negative charge. किसका concentration बढ़ रहा है? Cation. Why are you guys not speaking, guys? आप दूसरों के इंतजार क्यों कर रहे हैं? So concentration of cation is increasing. That means this particular compartment will be positively charged. Positive charge बढ़ रहा है ना इसमें? So it will be having a lot of positive charge in this compartment. Correct, guys? Yes or no? Please tell me.
Yes, sir.
Makes sense till here? Okay. Next, please see here what is happening in the copper compartment. In the copper compartment, copper 2 plus is getting neutralized by 2 electron. Copper 2 plus is going from solution to rod. This copper 2 plus is going from solution to rod. Can all of you see that? Yes or no? Please tell me. From solution to rod. Okay?
Yes, sir.
So what is happening here? The concentration of cation is? The concentration of cation is? In the copper compartment? बताइए, concentration of cation is?
Low.
हाँ, decreasing. सही है ना? क्या हो रहा है? Decrease कर रहा है. If the concentration of cation is decreasing, can I say concentration of anion is increasing? Relatively speaking, I can say that, right? So what is happening here? The concentration of anion is increasing. That means this particular compartment is becoming negatively charged. Is this clear? Yes or no? Please tell me. यहाँ तक clear है?
Yes, sir.
Now, what was happening? What was happening? Electron was going away from the zinc compartment towards the copper compartment. Electron was moving from zinc compartment to copper compartment. Once again, I will repeat it. You also repeat in your head. Electron, which is negatively charged, is going from zinc compartment to copper compartment. Zinc compartment to zinc
Copper
compartment to copper compartment. But after a while, when the zinc compartment will be highly positively charged and the copper compartment will be highly negatively charged, then the electron will say, wait a second, why I am going from positive to negative? Isn't the positive supposed to attract me? Zinc will also say, oh yes, yes, yes. After a while only, not in the starting, not in the starting. There will be flow of electron, flow of electron, flow of electron. The bulb will also glow. But after a while, the zinc compartment will become highly positively charged. The copper compartment will become highly negatively charged. Then the electron will say, wait a second. Why I am going from positive to negative? Isn't it supposed to be the zinc will say, wait. Electron come back. So zinc will attract the electron. And then what is going to happen? The zinc will not let the electron move towards the copper compartment because the zinc compartment has already become positively charged and the electron flow will stop. As the electron flow will stop, the bulb will stop glowing. Is this clear? Yes or no? Please tell me.
Yes, sir.
All of you understood this? Yes or no? Please tell me. Parker, Alia, Aisha, Hafsa.
Yeah.
Next thing. अब क्या करें? Bulb तो we should have the bulb glowing, right? You agree or agreeing with this? No, we have to study this status. Obviously, the bulb should glow. So what will happen now? They called some another scientist. They said that okay, sir, क्या कुछ हो गया यहाँ पे? Here we are having positive charge. Here we are having negative charge. So what should we do? The scientist, oh, positive charge, negative charge, simple. Positive charge, negative charge, simple. What we are going to do? Please see here. I will introduce another. I will introduce a device which joins both of these compartments. Okay? Both of these compartments are joined. And in this particular device, I will put a electrolyte. What type of electrolyte? I will put up electrolyte, for example, KCl. What is so interesting about KCl? Because here we have K positive and Cl negative. K positive and Cl negative. Now, as soon as the zinc compartment will be gaining positive charge, as soon as it will be becoming highly positive charge by the increase of Zn2 plus, chlorine will run, and it will reach the zinc compartment. Chlorine negative will neutralize the zinc. Because here we are having a high positive charge, the anion from this, we call it salt bridge, because here we are adding a salt and it is kind of like a bridge. So we call it salt bridge. From the salt bridge, the chlorine negative will run and it will neutralize the zinc compartment. As soon as the anion increases and the negative charge increases in the copper compartment, potassium will run and it will reach the copper compartment and neutralize the copper compartment. Is this clear? Yes or no? Please tell me, guys. All of you understood this? Yes or no?
Yes, sir.
Okay. So this is the story of a particular cell in which Barker, my voice is cracking. Is my voice cracking for everyone?
No, sir.
Barker, there is some issue with your internet. All of you understood this? Yes or no? Please tell me.
Yes, sir.
Yes, ठीक है. अब थोड़ी थोड़ी बात हम लोग यहाँ पे कर लेते हैं और ठीक है ना, ध्यान से सुनिए. Now, since zinc, this zinc is coming from rod. ध्यान सुनिएगा. This Zn2 plus is going to the this Zn. Can you explain the KCl part? My Wi-Fi was. Acha, fine. I will explain. Parker, am I audible now? Just say yes or no.
Yes,
Keep your
sir.
mic on also. ठीक है. So you understood now what happened in the zinc compartment? The what charge increases and increase in the zinc compartment?
Yes, sir.
What
Positive
charge? वो तो
charge.
बताओ. Positive charge. Very good. And what charge increases in the copper compartment?
Negative charge.
Negative charge. So I put up a bridge between these two compartments where I have salt such as KCl. KCl will have a cation which is K positive and anion which is Cl negative. Now, as soon as zinc positives, that means the positive charge will increase in the zinc compartment, the Cl from this particular salt bridge will come down to the zinc compartment and it will neutralize because zinc में positive है, Cl में negative हो जाएगा. बात समझ में आ रही है?
Yes, sir.
So instead of stopping the electrons, what the zinc compartment will do now? Zinc compartment will bring the Cl negatives. It will bring the Cl negative. Similarly, when the anionic charge will increase in the copper compartment will bring the K positive. The K positive will come running down and it will neutralize the copper here, whatever the anion is. Got it? Yes or no?
Yes, sir.
Okay, so that was it was just used for neutralization. ठीक है. अब थोड़ा सा हम लोग देखना चाहते हैं, थोड़ा सा और समझिए यहाँ पे. Here what is happening? The zinc from the rod, it is going and it is getting converted to Zn2 plus, and this Zn2 plus is going to solution. And this 2 electron is again in the rod itself. है ना? Electron तो पानी में नहीं जाएगा ना. Electron will be in the rod, in the metal itself. That is why it will go through the wire. So 2 electron is present in the बोलो भाई. 2 electron is present in the
Rod.
Which rod? Zinc rod. Na, which rod?
Zinc rod.
Zinc rod. So if 2 electron is present in the zinc rod will be having negative polarity. Correct? Yes or no? Please tell me. बताइए. सही है ना?
Yes, sir.
Or when zinc, it is having negative polarity and electron is flowing towards the copper compartment. So electron will flow to the copper compartment only and only if the copper compartment is what? Having a positive polarity. ये समझ में आया सबको? हाँ या ना, जल्दी बताएं. ठीक है. All of you understood whatever is happening here? Yes or no? Please tell me. All of the
Yes.
points? Yes or no? ठीक है. अब लिखिए. अब सिर्फ लिखना है, कुछ बनाना नहीं है आपको. ठीक है. बनाने का काम बाद में. सुनिए. सबसे पहले यहाँ पे पॉइंट लिखिए, गैल्वेनिक सेल. पहले सेल में लिखिए, प्लीज राइट द सेल in which Spontaneous redox reaction. Spontaneous redox reaction occurs due to which chemical energy is converted to electrical energy. Chemical energy is converted to electrical energy. Okay. And there are two compartments. एक को बोलते हैं एनोडिक कंपार्टमेंट, दूसरे को बोलते हैं कैथोडिक कंपार्टमेंट. ओके, वो बाद में लिखें. इसमें चलिए इतना लिख लीजिए. गैलोनिक सेल, cell in which spontaneous redox reaction occurs due to which chemical energy is converted to electrical energy. All of you done writing? Yes or no, please tell me. Raise your hand once you're done writing. See, camera सबका ऑफ हो गया. हाँ, 7:30 turn your camera on. What happened, Mariam Khatun? Mariam Khatun ने क्या बोला? Mariam Khatun, sir, Mariam Khatun did not say anything. Khatun, your camera is not on. Yes, Mariam Khatun. Hafsa, what about you? Why is your video not on? Hafsa, what is happening with your video, Mariam Khatun? Why it is black? Light नहीं है क्या आपके यहाँ? Saad and Hafsa, what happened? Your is, I mean, completely not visible. हाँ, ठीक है. You can lower your hand, all of you guys. So, in which spontaneous redox reaction occurs due to which chemical energy is converted to electrical energy. ठीक है. उसके बाद you write here, please write. There are two compartments. एक को बोलते हैं anodic compartment. What happens in anodic compartment? Please write. Oxidation occurs here. Its polarity is negative. ठीक है, polarity is negative. Next, right, cathodic compartment. Here, the reduction occurs here. And the polarity is positive. क्या वो सब बोर हो जाते हैं क्या? कैमरा क्यों बंद हो जाता है आप लोग का धीरे धीरे? I don't understand this. हाँ guys, what happened? साद, मरियम खातून आप कुछ फिक्स कराइए. I don't know what is happening. चलिए, कैथोडिक कंपार्टमेंट एंड एनोडिक कंपार्टमेंट लिख लिया. अच्छा, कैथोड एनोडिक कंपार्टमेंट को we will also call it anode in short. And cathodic compartment को we'll call it cathode. ठीक है, cathode and anode. Now, please write Daniel cell. Daniel cell. Daniel cell is what? Daniel cell is the copper zinc cell. The copper zinc cell that we just made was the Daniel cell. So in Daniel cell, there are two compartments. We have the zinc compartment and the copper compartment. So first of all, you will write at a zinc compartment. First of all, at zinc compartment. So what is the reaction at zinc compartment? So in zinc compartment, the reaction that is happening is zinc is giving Zn2 plus 2 electron. This 2 electron is going to the rod. Now, also this particular zinc 2 plus 2 electron, that means it is anode because oxidation is occurring here. Can you see oxidation? Losing of electron, loss of electron is oxidation. And also because it is anode, it will be what? Negative polarity. The polarity will be negative. Polarity will be negative. Polarity will be negative. Then we have और लिख सकते हैं यहाँ पे at zinc compartment. The mass of zinc rod, the mass of zinc rod decreases because zinc is going from rod to solution, and concentration of zinc 2 plus is increasing. At copper compartment. What is happening in copper compartment? Copper 2 plus is getting 2 electron. It is getting converted to what? It is getting converted to copper. अच्छा, what is this? ये यहाँ पे this is reduction reaction. I hope आपको दिख रहा है. This is the gain of electron. That is why it will be reduction. Next, since it is reduction, it will be what? It will be cathode, and it will be also polarity will be positive. Next, please see. So copper 2 plus is coming from the solution and it is going to the copper rod. So what we can write here? We can write the mass of copper rod increases and concentration of copper 2 plus decreases. Write this down. Raise your hand once you're done. You know what? Your batch is the one who is not turning the camera on. क्या हो रहा है? I really don't understand. Hafsa, what happened? Hafsa, can you? अब कुछ तो बोलोगे Hafsa? आप नहीं बोलोगे. Why your camera is not on, Hafsa? Hafsa, am I audible? Guys, you are not the only one who are attending the classes on the phone. Okay, you can keep the phone like this, and you can keep the camera on. अब phone को क्या कीजिए ना? If you have phone something like, for example, this is your phone. You keep the phone like this somewhere, ना? इस तरह से phone को you will camera on करने में क्या है? If you're attending from phone, you don't have to keep the camera like. ऐसे भी तो रख सकते हैं. I mean, you don't have to hold it up. You can keep it up. You can get a support from a copy, get a support from a pen also, it will be there. Get support from the wall. You understand what I'm trying to say, Hafsa? Same thing for Parker also. Parker, you must have a wall, right? You don't have a wall where you sit and study.
No, sir. Actually, there is space between my table and the wall because there is a socket behind it.
Do you have a notebook? कोई एक्स्ट्रा कॉपी या फिर टेबल है ना? कुछ ही चीज का भी तो सपोर्ट रख करके रखा जा सकता है ना, कि नहीं रखा जा सकता है? बताइए. You can have a support of anything, na? Leave if it is not a wall. You can have a support of a notebook. You can have a support of a book. You get a thick book, maths book रख दीजिए, उसके ऊपर ऐसे रख दीजिए फोन. You can have it like this. गिर गया आपको phone. ये हम तो बहुत ज्यादा नहीं बोलेंगे आप लोग को. You have to socially discuss from here only. ठीक है. So someone was asking how will the question come from this topic, है ना? See, the question can come in various ways. एक question तो यही आ सकता है सीधा, what are the reaction happening at zinc compartment and copper compartment? Which is the cathode? Which is the anode? What is the polarity? है ना? So what is the? I mean, all of these points that I have written, they can be asked in the question. What happens to the mass of zinc rod as the reaction occurs? So mass of zinc rod will decrease. The concentration of Zn2 positive will increase. ठीक है? All of these questions can come in the question. Are you getting my point? Who asked this? Khatun. Khatun, you understood how the question will come? Okay. No. Please see. Next point. So we will also write the reaction that is happening at anode and cathode. So at anode, as you saw, what is happening? Zinc is giving Zn2 plus 2 electron. See, those who are having the cameras on but their face is not visible, this is, हम एक बार बस आपसे कह रहे हैं, इस बार हम आपसे नहीं बोलेंगे कुछ ज्यादा. अगले क्लास में, in the next class, please have your camera set up in whatever manner, but your face should be there. In cathode, what is happening? Copper 2 plus 2 electron is giving you copper. When you see in both these anode and cathode, 2 electron is in the product side, 2 electron is in the reactant side. So you can cancel these 2 electron, and always in the cell reaction, in the complete cell, the electrons will be cancelled. And I will write zinc plus copper 2 plus gives you zinc 2 positive plus copper. This is the cell reaction. Please write this down. Once you are done with the anode and cathode reaction, you will write salt bridge. So what is salt bridge? Please write. It is inverted U-shaped tube. It is inverted U-shaped tube containing solution of inert electrolyte with agar-agar or gelatin in semi-solid form. So agar-agar and gelatin, these are kind of pastes, and in that paste you have to add inert electrolyte. Why inert electrolyte? The electrolyte whatever you are using, for example K plus and Cl negative, they should not be doing any reaction with the components of the anode or the cathode. So what you can use, examples are KCl, KNO3, NH4NO3, etc. So these are the different electrolytes which can be used inside the salt bridge. Next, you will write the functions of salt bridge. Functions of salt bridge. तो मैंने लिखे यहाँ तक फंक्शन लिखा है हम. All of you done writing till salt bridge? If anyone is not written, please let me know. Please write function of salt bridge. As we have seen in salt bridge, first of all, it connects the two half cell. Please write it connects the solution of two half cell to complete the circuit. To complete the circuit. ठीक है? To complete the circuit. Now, write next. Two half cell to complete the circuit. Second point, please write. It maintains the electrical neutrality. The electrical neutrality of the solution. As we saw, when the zinc compartment was positively charged, Cl negative came down and neutralized it. When SO42 negative was very high, or we can say the copper compartment was having a larger anionic charge, then K positive came down and it neutralized what? It neutralized the copper compartment. So it maintains the electrical neutrality of the solution. Third point, please write. It minimizes the liquid junction potential. It minimizes the liquid junction potential. ठीक है? Now, what is liquid junction potential? ये बाद में आएगा. और इसको आप ना मेरी तरफ से मान लीजिए. It minimizes the liquid junction potential. This is something that you have to remember and learn. All of the first 2 points you can easily understand that it is completing the circuit. है ना? If the electrical circuit is there, it should be complete. So thus it is connecting the circuits and then maintains the electrical neutrality. We have understood it. It minimizes the liquid junction potential. मेरी तरफ से मान लीजिए ये है. After this, you will write observations in. Let me know if you have not written. After this, you will write observations made in galvanic cell. Observation made in galvanic cell. ठीक है? Number 1. You try to remember the zinc rod wala case and copper rod wala case, है ना? Please write. Tell me, है ना? Mass of anodic rod increases or decreases? Tell me, guys. Mass of anodic rod will increase or decrease? You try to see the zinc wala part and tell me. हाँ, Mariam Parker, tell me.
Increase.
Increases. Guys, please answer. ठीक है? जो आंसर नहीं कर रहे हैं उनको बहुत बाद में दिक्कत होगी. ठीक है, guys? All of you, please try to answer. Mass of anodic rod increases. Mass. Next, लिखिए concentration of metal ion at anode. है ना? एनोड में जो सोल्यूशन है वहां पे मेटल आयन क्या हो जाएगा? The concentration of metal ion will increase or decrease? एक सेकंड, माय बैड. एनोडिक रॉड डिक्रीज करेगा ना? पार्कर, आपने डिक्रीज कहा था इंक्रीज कहा था? क्या कहा था पार्कर? इंक्रीज कैसे करेगा? जिंक रॉड क्या है? जिंक रॉड इंक्रीज कर रहा लिखा है क्या हमने? द मास ऑफ जिंक रॉड. देखिए आंसर नहीं करेंगे, सिर्फ लिखिएगा तो यही होगा यार. लिखो ना ही कोई. नो वन इज टर्निंग देयर माइक ऑन, नो वन इज आल्सो आंसरिंग. दिस चैप्टर विल बी अ पेन फॉर ऑल ऑफ यू गाइस. लिखिए, चुपचाप से लिखिए. कंसंट्रेशन ऑफ मेटल आयन एट एनोड इंक्रीजेस. नेक्स्ट में लिखिए मास ऑफ कैथोडिक रॉड Mass of cathodic rod will increase. Concentration of metal ion at cathode will decrease. What else we can say here? Electron moves from एनोड टू कैथोड. रटना चाह रहे हैं आप लोग? अगला पॉइंट और क्या बोल सकते हैं? ऑब्जर्वेशन मेड विल बी if I remove the cell stops working. On removal of salt bridge. Cell stops working and removal of salt bridge. सब चीजें याद करनी पड़ेंगी फिर आप लोग को. अगर समझना नहीं चाह रहे हैं आप लोग ना तो याद करनी पड़ेगी. Let me know once you're done. Right, next. Cell representation.
Sir?
Tell me.
Sir, can you please scroll up?
Okay.
Done, sir.
Assalamu alaikum, Amna. How are you?
Walaikum salam, sir.
Why are you so late, Amna? You're 1 hour, more than 1 hour late.
Yes, sir.
What happened?
I got late for my school, so.
You got late from your school.
Yes.
What time did you reach this home?
6:15.
How will you attend the classes then?
From tomorrow I will be on time.
Maybe. How will you be on time if you are reaching home at 6:15? Yes, Amna, tell me.
Today we came by private bus, so it was late. So tomorrow onwards it might be early.
Okay. So at what time your school ends?
5, sir.
5 o'clock. Okay, so it is, I mean, the class is almost going to end. We have only 20 minutes left. Okay. So you'll have to watch the recording. Okay.
Yes, sir.
Right. All of you guys, please write cell representation. So cell representation is very easy. You remember these 3 words, A, B, and C. So A is for anode. B is for bridge, salt bridge. We represent the salt bridge like this. And C is cathode. And C is cathode. Okay. So this is the cell representation. This is the way how we are going to write the cell. Achha. For example, if you are having, please see. For example, you have the zinc and copper. Okay. So I will write something like this. Oxidation is shown in anode. Second, reduction is shown in cathode. Now, if you remember the zinc and copper cell, then in the anode part, what we'll write? We will write it like this. Zinc is getting converted to Zn2 positive. So this is the reaction happening at anode. This is the oxidation reaction. Zinc is getting converted to Zn2 positive. This is very important. Please try to understand. Na? Please try to understand here. This is very important. We are going to write oxidation. What is oxidation? From lower oxidation state to higher oxidation state. That is the loss of electron. That is why zinc to zinc 2 positive. This is oxidation, not the other way around. not the other way around. In anode, you will always write oxidation reaction. In cathode, what is happening? Can anyone tell me? What is happening in the cathode? What reaction is happening at the cathode? In copper compartment. What reaction is happening at cathode in copper compartment?
Reduction.
Tell me what is the reaction, actual reaction?
Copper
Yes,
receives 2 electrons and
copper
becomes.
बोलिए copper
Receives 2 electrons and becomes Cu.
So copper 2 positive, right? It is getting converted to copper.
Cu.
All of you got this? Yes or no? Please tell me, guys.
Yes, sir.
Okay. Okay, now please. This is one way. There are plenty of things that you can see in the representation. Okay, please see here. Don't write anything. Don't write now. Now, zinc is solid, so they will show like this. They may show you something like this: zinc solid. And when Zn2 plus is aqueous, they can show you Zn2 plus aqueous, right? And the bridge will be as it is. Here you have copper 2 plus, so copper 2 plus will be aqueous. And copper is solid, so copper will be solid. What else they can show you? They can also give you information. For example, zinc solid and Zn2 plus, which is present here, it is present in 0.1 molar solution, for example. Then they will write the bridge. They will give you information about the copper 2 plus. So copper 2 plus has a solution, it is 0.01 molar. It is getting converted to copper solid. So you don't have to worry about the other things that they have given. If they are giving you some information, you will just keep that information in your mind. You don't have to worry. There's nothing changed here. The cell is same in the first case, in the second case, in the third case. Only the information is increasing from the first case, second case, and third case. Is this clear? The oxidation reaction is still zinc to zinc 2 positive. The copper reduction is still copper 2 positive to copper. But the level of information is increasing. Is this clear? Yes or no? Please tell me. Is this clear, all of you?
Yes, sir.
They can also show you something like this: zinc solid to ZnSO4. We have bridge copper CuSO4 to copper. They can also show you something like this. Okay. So all of these are same thing. There's nothing different happening. You have to identify the oxidation at anode. You have to identify the reduction at cathode, and then you have to represent the cell. Now I will be giving you certain reactions. I will be giving you certain reactions. You have to represent the cell. Is that clear? Yes or no? Please tell me. Is it clear,
Yes,
guys?
sir.
All of you? Can I move on? All of you have written this thing. All of this oxidation is shown in anode, reduction is shown in cathode. If everyone is written, please write a question. Represent the following. Reaction as galvanic cell. Like number 1. Here you have copper 2 positive plus Mg is giving copper 2 positive plus Mg is giving Mg2 positive plus copper. First of all, you will identify whatever the changes are happening. We are moving from copper to copper. Copper 2 positive to copper. So what is happening here? Oxidation or reduction, guys? What is happening? Oxidation or reduction? Copper 2 positive to copper. All of you can identify this. If anyone cannot identify oxidation reduction, please raise your hand. This is very important. Raise your hand if you cannot identify. Raise your hand if you can identify oxidation and reduction. Raise your hand if you can identify oxidation and reduction. Okay, Alia. Amna also. Amna, you have difficulty? Amna can also. Hafsa, can you identify oxidation reduction? Yes, Hafsa.
Yes, sir.
Raise your hand. I can't hear you actually. Raise your hand. If you are not raising, that means you cannot identify. No? Okay, all okay. Okay. Fine. Then it's okay. You can lower your hand, all of you guys. Copper 2 positive. This is, tell me guys, what is this? Mariam Patun, correct. Very good. So this is reduction. And this is oxidation. This is oxidation. Now, if it is reduction, reduction occurs at where? Tell me. What will happen at anode and what will happen at cathode? Tell me guys, anode and cathode. What will happen at anode and what will happen at cathode? बताइए reduction है इसका मतलब क्या? Reduction occurs at, tell me guys, reduction occurs at, ये बताइए chat में, all of you guys. The chat please quickly. Chat में बताइए जल्दी. Reduction occurs at, yes, Alia correct, Mariam Parker correct. नहीं, Hafsa. You cannot be wrong in this particular section, Hafsa. Pay attention, guys. What I can say. You have written already, na? If you are not clear about something, please look back, guys. Please look back. Don't say the wrong answers. If you're confused about something, please look back. Reduction always occurs at. Hafsa, turn your mic on na, as soon as I take your name. You have done it wrong. Yes, Hafsa. Reduction occurs at. Bataiye, where does reduction happen? Reduction occurs at. Yes, Hafsa. Cathode, na. So why are you saying anode? Do you want me to have a? Do you want me to have a heart attack? Hafsa. Where does oxidation happen? Tell me, guys. Anode or cathode? Oxidation occurs at. Boliye, guys.
Anode.
Very good. It happens at anode. Basically, what you need to write A, B, and C. What is happening at anode? Mg2 plus. Bridge. What is happening at cathode? Copper 2 plus 2 copper. Please write this down quickly. Let me know once you're done. Also, please just see this thing. There is no role of the stoichiometric coefficient. You don't have to write 2 mg or 1 mg if ever you see the stoichiometric coefficient. You have to just write the chemical species. Please understand what I'm trying to say. You have to just write the chemical species. Amna, is Sidra with you?
Yes, sir.
We are okay with these concepts of electrochemistry?
Yes, sir.
Okay. Parker, I am saying that you only have to write the chemical species. For example, copper 2 plus is a chemical species. If I write here 2 copper 2 positive, that 2 will not be shown in the representation. Got it? Listen, please tell me. Parker, समझ में आया? If you're done writing this, write the next question. Aluminium plus copper 2 positive will give you aluminium 3 positive plus 3 copper plus copper. If you want to balance it, the balancing will be something like this: 3 copper and 3 copper 2 plus. So it will be 2, and here you'll have 2 aluminum. Identify the species which are getting oxidized and the one which is getting reduced. Once you are done, you will send me the answer on this particular number. Okay. Amna and Sidra, you will save this number and send it to me. You have to give the cell representation. Mariam, I need the. You don't have to tell me that, Mariam Khatun. Send me the cell representation like this. Okay, Mariam. Mariam Khatun, you got it? ओके थैंक्स। क्लास के बाद भेज दीजिएगा मरियम खातून, आप एक बार चेक कर लीजिएगा ना, ठीक है ना, छोड़ दीजिए तरह भी आप कुछ कर लीजिए। सबसे वेरी गुड पार्कर, पार्कर वेरी गुड करेक्ट। आयशा वेरी गुड, ये करेक्ट है। आमना एंड सिद्रा, आमना एंड सिद्रा,
Yes, sir.
डन।
Yes, sir.
Send me a photo na on WhatsApp.
Yes, sir.
Please save my number quickly. Rabia, what happened? Did not get your answer, Rabia. I'm not done. डिलीट कीजिए फिर। एल एल हाँ ठीक है, सही है। आई एम वेटिंग फॉर राबिया, आई एम वेटिंग फॉर आमना। Those who have sent me your answers, your answers are correct. Hafsa, Mariam, Parker, and Aisha. Also, Alia, your answer is also correct. I'm just waiting for Rabia. Rabia, am I audible? What happened? You're not even speaking now.
Yes, sir.
Please send it quickly now.
Yes, sir. Give me a few minutes.
Few minutes? What happened? Why do you need few minutes?
Sir, my WhatsApp is not working.
It's fine then. Leave it. Send me once you're done. Okay, once it is working. Now, please see here, guys. I'm not writing the answer right now. Those who have sent me till now, all of your answers are correct, so I don't need to explain. Those who have not sent me, I don't know their answers. That is why I'm not writing. So, Amna and Rabi, you have to send your answer. Amna, Sidra, and Rabia. See here, guys. So, next we have to write the cell reaction. Write the cell reaction occurring at following cells. I've got an answer, I guess. Yes. Yeah, correct. Very good. So this is both of your answers. आप लोग एक ही notebook में लिख रहे हैं. Sidra and Amna. Whose answer is this?
Sir, mine, Amna.
And where is Sidra?
Yes, sir, sending.
Sending. I hope तो दोनों का same ही होगा फिर तो answer. Both of your answer will be same, ना?
Yes, sir.
ठीक है, पता नहीं दीजिए, छोड़ दीजिए. See here, guys. Write the cell reaction occurring at the following. Now, please see. For example, I have something like this. Number one. Still, you have sent. I mean, I have to see handwriting. Why your handwritings are different? Sidra writes a bit more. Sidra ने पहले गलत किया था. Sidra.
Yes,
Sidra.
sir. I got
Why?
confused between anode and cathode. So, yeah.
Anode and cathode. A, B, C. A, B, C. Anode, bridge, cathode. You know ABC, right?
Yes, sir.
ओ अच्छा, आप उल्टा चले गए क्या? अलिफ, बा and tha. Did you go like this or what?
No.
I hope you did not go that way. It's ABC, not alif, ba and tha. Okay, fine. Mariam has sent me right now. Mariam. Yes, and positive to copper. Yeah, correct. Very good, Mariam. राबिया का आंसर नहीं आया अभी तक. हाँ, I got it. Mariam, I got it. Please here, guys. For example, if I have a cell like this, nickel 2 positive, this will be obviously anode, and oxidation is happening here. I have a bridge, and here I have Ag positive, which is getting converted to Ag, silver. Now, in this particular thing, what is a cell reaction? They're asking me the complete cell reaction. So I have to write for anode and cathode. So what is happening at anode? Can you please tell me? Nickel gives nickel 2+, and how many electron, guys? Please tell me quickly. Have your mic on. When I'm explaining, keep your pen aside and try to answer me. Okay, please have this a habit. Tell me, how many electrons?
2.
2 electrons. Very good. Now, in cathode, what will happen? Ag positive will eat how many electrons? Ag positive will eat how many electrons? 1 electron. Ag positive will eat 1 electron to get converted to Ag. Now, whenever you have different number of electrons in anode and cathode, you have to balance the electrons always. If you are writing a cell, this is only applicable for the cell reaction. It is not applicable for the half cell reaction. That is, in anode you can have electron, in cathode also you can have electron, but in the cell reaction you cannot have the electron. Is that clear? Yes or no, please tell me, guys. In the cell reaction you cannot have the electron. So what I will do, how I will balance? If you remember the pair of linear equation in 2 variable, उसमें जब आपके पास इस तरह का condition आता था, what you should do? You will multiply 2 here. So this will become 2 Ag, 2 electron and 2 Ag positive. All of you got this? Yes or no, please tell me, guys. जल्दी बताएं.
Yes, sir.
All of you understood now? Multiplying of 2. This is nothing new. I hope this. Okay. Now, then I can cancel this 2 electron from here and here, and I will get nickel plus 2 Ag positive is going to give you nickel 2 plus 2 Ag. Write this down quickly. Write the second one. Parker, can turn your mic on? Yes, Parker, please. Earlier we had here 1 electron and 1 electron, right? Parker?
Yes,
Ag
sir.
plus will eat 1 electron to give 1 Ag. We have to balance the 2 electrons. So 2 electron was there in nickel. I have to have 2 electrons in the Ag reaction also. So I multiplied this whole reaction with 2. So I got 2 Ag plus 2 electron giving 2 Ag. Now I can cancel the 2 electrons. Got it?
Yes, sir.
Okay, that is it. And the next one, Zn2 positive. राबिया ने अभी जाके भेजा है. यही तो हम बोल रहे थे राबिया आपको, that we have to write only the chemical species. The stoichiometric coefficient has no role in the cell representation. कुछ याद आया राबिया?
Yes, sir.
So you don't have to write that 2Al. You don't have to write that 2Al3 positive. You don't have to write the 3Cu2 positive and 3. 3 or 2 numbers नहीं लिखने. You have to write only the chemical species. ओके क्या सुना था फिर आपने राबिया? इतना तो हमने खोल खोल की चीजें बता दी. ट्रिक भी नहीं करते हम आपको, है ना? सीधा सीधा बता देते ये करना है ये नहीं करना है. प्लीज हियर गाइस द नेक्स्ट वन. सो इन एनोड व्हाट इज हैपनिंग? zinc is getting converted to Zn2 positive. Bolo bhai, bolo. Plus how many electrons?
2.
2 electrons. In cathode, see, whenever you are writing for cathode, na, and see, electrons will always be a mystery in cathode. So you will always write it like this. H plus will give you H2. H plus will give you H2. Now, first of all, you will balance this whole thing. H hydrogen, here you have 1 hydrogen, here you have 2 hydrogen. So you will balance this. You will write here 2H positive. A balance of, now atoms are balanced. Yes or no, please tell me, guys.
Yes,
Atoms
sir.
are balanced. Now you will balance. Here we have 2 positive charge, so there will be 2 electrons also. Got it? Yes or no, please tell me. First of all, you will balance the atoms. Then only you will balance the you will add the electrons. And अगर थोड़ा सा आप लोग और ध्यान देना तो आपको ये नजर आएगा that when we are adding the electrons, we are actually balancing the charges. We are actually balancing the charges. I'm trying to ask something. Please keep your pen aside and try to answer. Keep your pen aside. What is the charge on zinc? Is there any charge on zinc? Can you see any charge on zinc?
No.
No. So this is LHS. This is LHS. LHS is having neutral. Is neutral. It is having 0 charge. It is having 0 charge. Correct, guys?
Yes, sir.
What about here? What is the net charge on the RHS?
Positive.
2 positive and 2 negative. Again 0.
Yes, sir.
Okay. So this is how you have to write the number of electrons. If you are having 2 positive, you have to write 2 electrons. Here I am having 2H positive, 2 electrons. Okay. Here also you can see it is neutral. 2 positive, 2 electron. Here also it is neutral. Okay. Now I can cut these two. You will get zinc plus 2H positive giving Zn2 positive plus H2. बात सपोज समझ में अब आपका सवाल होना चाहिए सर ये प्लैटिनम कहां से आया? What is this platinum doing here? So we'll say that, see here guys, H2 is a gas and gas directly cannot go and react inside the H positive, so it needs a surface. No? Gas needs a surface, so platinum is just providing surface. Ki aaja bhai gas, sit here, and then H plus will be getting converted to H2. Okay, so H plus is interacting with the electron. ऐसे हवा में तो electron नहीं रहेगा ना? It has to come in a wire, and that wire will be on the platinum. Now that wire is attached to platinum. The platinum will now have the electrons. The H plus will be connected to what? H plus will be connected to the platinum. इस तरह से. If I will make the electrode, here you will have the glass type something. The wire will come here, and here you will have the platinum. This is platinum, and here you have HCl solution, which is having H plus ions, and these are getting converted to H plus, and electrons are coming here, and it is getting converted to H2. So this platinum is just providing surface. Okay, so all of these, whatever we have done now, all of these are questions which can be asked. You can be given a cell, asked a reaction. You can be given a reaction, you can be asked about the cell. That is it for today, guys. In the next class, we will talk more in terms about the quantitative analysis. This is qualitative. What is happening? What is getting converted to what? How we are representing things and everything. Numbers, we have not included numbers till now. Sir, where in this answer will we use platinum? No, you will not use platinum. Platinum is neither getting oxidized nor getting reduced. It is just there. No? So we will not neither write it in anode nor in cathode. So we will only write in anode what? We will only write